19, 21, 23, 25, 23, 25, 31, 35, 37, 39, 41, 43, 45, 47, anyone else left from other batches? So any question from the last? Any question from the last lab?
No, sir.
Did you guys try in Python as well, or only in MATLAB?
Only in MATLAB.
You should try in Python as well. Otherwise, within a few months, we'll completely forget Python. Okay, and you should keep at least, these are simple things, not a difficult thing. So if you keep practice, it will be easier to do things later when you need, if you need to do things in Python. You completely forget, that will be a problem. Okay, so today's experiment is experiment 2. Before I start, okay, so do you remember the last experiment? Experiment 1.
Yes, sir. Sir, are you going to conduct today's experiment with Python?
No, in MATLAB. I'm just going to show you the experiment 1 in Python. It will take only 1 minute. Can you see the screen?
Yes, sir.
Yes, sir.
Okay, so what we did first is that I'm not going to go into details. I'm just going to show you how to do it in Python. Okay. First, we created a vector. First, I have to import some libraries. For example, import numpy as NT. Okay. Then I created a vector from 0 to 10, right?
Yes, sir.
So to do that, I can use the range function, the numpy range, because I want to create a numpy array. I want to start from 0 to say 10 or 12. And I don't need to write 0 because that's the default operation. Just by writing this is enough. You can check the vector now. That is from 0 to 11, right?
Yes, sir.
Okay, now then our task was I wanted to perform 0.5. We use 0.5 to the power this vector, right?
Yes, sir.
Yes. So we can do this like this way. NP dot exponential. Okay. So 0.5 comma my vec. So our original equation was, can you see this screen?
Yes, sir.
Let me take the first. Lab one. So wait a second.
Sir, does this function works element wise?
Yeah. Let me open the lab one first. I forgot the things. It was the original equation. Lab one. Lab one. Okay, so yeah. Can you see now?
Yes, sir.
So the task was x to the power something. Okay, our true value was exp 0.5, right? E to the power x. This was our true value, and we calculated using Maclaurin series. The Maclaurin series was x to the power n divided by n factorial, right?
Yes,
Summation.
sir.
Summation of,
Sir, it was Taylor series, right, sir?
yeah, Taylor series. Taylor series approximated into Maclaurin series. In Taylor series, it was x minus a in the last term. When you are converting into Maclaurin series, we have to consider a is equal to 0. The point you are taking the differentiation, that's nothing. That's not important now. Let's come here. Okay, so NP of exponential of 0.5. This is my true value. My true value. That is my true value. Now I want to perform this operation x to the power n in a vectorized way. So that is this is my a is equals to np dot power operation, right? Power, first parameter is the 0.5 to the power my vector. Okay. Then a. Okay, so this is my values of a. There are total 12. So there are 12 values, right? This is 12. In Python, the last one is outside. Okay, up to 11. That means from 0 to 11. This is my a. That means this is my upper term. That is x to the power n. I have calculated. Then I need the denominator, that is n factorial, right? N factorial. How to calculate the factorial? Now, in normal function that is available in math library that does not perform vectorized way. So I have to do something different. I have to import something from SciPy. SciPy is another library. Okay. Import SciPy. Yes.
Sir, is it doing the power? So is it is it doing everything vector element wise? Like we didn't do anything to show that it's doing element wise vectorization, which we did in MATLAB.
Yes, it is doing it vectorized way. It automatically consider itself if the vector is a vector. If this vec is a vector, it will automatically perform vectorized operation. That means all the elements in the vector will be power of 0.5.
Okay.
I don't have to specifically write dot to the power in NumPy.
Okay.
Okay, this power function will automatically handle that. So I want to, from SciPy is another library like NumPy dot special. From SciPy dot special, I want to import the factorial function. The same factorial function is available in math library as well, but that will not work for factorized operation. So my b, let's write a denominator. Denominator is equals to now the factorial of my vector. Okay, there goes my denominator. So these are the values of the denominator. Okay, 0 factorial equals to 1, 1 factorial equals to 1, 2 factorial equals to 2, 3 factorial equals to 6. So it is all right. Then
Sir.
remains, yes.
Sir, you have written that from SciPy, cannot we directly use import SciPy?
Yes, you can import SciPy, then you have to write scipy.special.factorial like this way.
Oh, sir, in that case, if we use that NumPy, we can use like import np dot import array from NumPy something.
Yes, you can. Of course, you can. The syntax is if I write like this, so import SciPy, then when I was calculating the denominator, I have to like this way. SciPy dot which one I want to use special dot factorial like this way. Okay.
Okay, sir. Got
Then
it,
you
sir.
have to do it like this way. Similarly, for NumPy array, you can import NumPy, then you can use it like this way. Okay. You can import from NumPy, import something like this. You can anyway use work. You can also use something like this. Let's not show you. There is another, yeah. So if you write from NumPy import, sorry, from SciPy, from SciPy.special, say for example, from SciPy.special import, if you use this asterisk sign, okay, that means everything that is under this one, SciPy.special, all the function, all the methods that are under will be imported by this. Okay, then you can directly access as well. So there are different techniques to call it. Okay, let's just focus on our task. Now I have to just divide this one with this one, right? A divided by B. So my let's C is equals to A divided by the denominator. So this is my C. The only thing remains, I have to sum those things, cumulative summation. So the D right here, D is equals to np dot cumulative summation. Same function available that was available in Python, MATLAB, that is also available in NumPy of C. Okay, then comes the D. So this is my 1, 1.5, 1.625. I believe this is the value is correct. You can check later. Is it clear?
Yes, sir.
Do you have any questions regarding how to do it in Python? Anyone?
Sir, actually forgot a format. Suppose I want up to 15 digit like MATLAB, then
Yeah.
what should I do?
Up to 15 is I don't understand. Oh yeah, the
Like-
format.
Yes, sir, the format.
Well, Python actually supports long format. It is in the scientific term. It is showing in the scientific notation. There is a function that is probably you can check format. There is a format option. Okay, you can point 2f. If you write 0.2f, something like that, then it will show up to 0.2 decimal like this. You can check this function in the internet. I don't remember. I don't normally do this thing. Okay.
Okay, sir.
That means whatever value you have, if you write 0.2, then it will show up to 2 decimal point. If you write 0.4, it will show up to 0.4 decimal point like this. Okay. There is this format option. There is D option, D, then F. There are different one. You can check the documentation. Is it clear?
Yes, sir.
Any other question? Okay, another thing. So to plot, how do we plot in Python? I have to use if import matplotlib. Okay, matplotlib dot pyplot as plt. Okay. So matplotlib is the plotting library of Python. Okay, it is the most used. There are other libraries like Seaborn. Now matplotlib. There are different libraries for plotting. The most used one is the matplotlib. Okay, it was created in 2004. It was created in 2004 by John Hunter. Okay, he was very much fascinated by MATLAB programming language, so he wrote this library, this plotting library, using MATLAB syntax. So when you are using matplotlib, you will see that the syntax is very much similar to what you used in MATLAB. Okay, when you are using matplotlib in Python, you will see the syntaxes of matplotlib is very much similar to MATLAB as well. This is an old library. A more new version, the new library is Seaborn. Okay. The graphics in Seaborn is much better than this matplotlib, but you can use both of those things. And Seaborn uses matplotlib as its backend. Yeah. Okay. Let's come here. So import matplotlib.pyplot as plt, then plt.plot, just plot. plt.plot. What I want to plot? I want to plot D, right? As you can see, this is increasing. So 1.6 something, 1.648, that was our true value. And it is with as I increase the term of iteration, increase the value of n, it is slowly going to the real value. Is it clear?
Yes, sir.
Okay, let's come to today's experiment now. So that is.
Sir, can you show with the another library? I mean the plotting library. Seaborn.
Yeah. Import Seaborn.
Yes, sir.
Yes.
Seaborn and SNS. Okay, it is installed. So, for example, what I want to plot? Bar plot. So, okay, so the values are actually almost similar. So bar plot. What do you want to see actually?
Sir, like the graph that you used in the matplotlib, the typical graph.
Oh, okay. Let's check. For plotting Seaborn, probably use some other. Does it use for plotting?
For Seaborn, it is
Seaborn এর
line
plot
plot
option যে কি আছে আমাকে দেখতে হবে একটু।
So line plot means.
Okay, line plot. Line plot. Let's check. Now let's see. X and Y must be specified. So X is my 0 to 10, right? It is fake. Okay, as you can see, this is working. In Seaborn, okay, in Seaborn, the command is line plot. Okay, in matplotlib, that is normal plot. In Seaborn, the command is line plot, but you have to specify the X as well as Y. Okay, so the X that I used was this fake, that is 0 to 11, and the D is the vector points, the points that we calculated. Is it clear?
Yes, sir.
Don't worry about, you don't have to always memorize all of these things. You can just check the documentation and that's completely fine. Okay. There are so many functions. Achha, let's come to experiment 2 now. Our today's experiment 2. Okay. Achha, so experiment 2 হচ্ছে finding the roots. Okay. Finding the roots. You have to find the roots of nonlinear equation. Nonlinear equation. Okay. So how do we find the roots of the nonlinear equation? For example, you have previously worked this simple expression like this: x square minus 5x plus 6. Okay, x square minus 5x plus 6. The roots of the equation, do you remember how to calculate it?
Yes, sir.
If we take x common, it is x minus 3. Then 2 common, it is x minus 3 again, like this. First, we have to dissolve it into minus 3x minus 2x minus 3 minus 2 minus 5, 3, 2 is equals to 6. 3 into 2, that is equals to 0. So you can say that x minus 3 into x minus 2, that is equals to 0. So the roots are 2 and 3, right? These are the roots of this equation. Okay, so your equation is f of x, function of x, that is equals to x square minus 5x plus 6. Okay, and for the value of 2, for the value of x, the x value, if the x value is 2 or 3, then this equation will be the value of function of x will be 0. Okay. But this is a simple equation. If we have a much more complicated equation, okay, much more nonlinear equation, then what can we do? For example, say for example, your f of x is equals to, the equation is given, you don't have to memorize, it's given in your book, 678 divided by c, okay, divided by c multiple by 1 minus exp to the power e to the power minus 0.1468 multiple by c. Okay, 1 yeah, 2 yeah, minus 40. Okay, so this is one equation, the equation of drag coefficient. Okay, this is the equation of drag coefficient of a parajumper. Okay. So in parachute, so this is a parachute. Okay, in parachute, so for example, this is a man. The gravitational force is acting downwards, right?
Yes, sir.
And the drag force, the drag, is actually acting upwards. Okay, so if there is no drag force, then the gravitational pull will take it free fall. Okay, the person here will cause a free fall here. Otherwise, if there is no acting force in the opposite direction, that is the drag force that is acting in the opposite direction. And this is one equation to calculate the coefficient of this drag force. Okay, drag coefficient is c. Okay, this other values, the actual equation is something like this. Let me write it like this way: f of x equals to g m divided by c multiple by 1 minus e to the power minus c divided by m multiple by t minus v. Okay, the values that I actually placed here is actually the taken values for this. For example, the value of z is 9.81. Okay, the value of m means the weight, the mass of this object, that is the person. It was taken as 68 something. It was given in the book, so I just took the same value. If I multiply this two, I get this value. Okay, then 1 minus e to the power, then cm t is the time to free fall, that is 10 seconds was taken, and the velocity of that person is 40. Okay, so I have taken this value. This is the equation. Okay, in this equation, by placing the values that we known is gm, then t and v, we want to calculate the value of c. That means I want to calculate the root of this equation. Is it clear?
Sir, we will find out the value of c.
Yes, we want to find out the value of c, this value. I have two parameters, right? In the exponential term, I cannot find the value of c like this way, as simple as this. I have one term in this one and one term in the exponential term. There is another c. So I cannot calculate it manually like that previously. So how can I calculate that? This is the problem definition. Is it clear?
Yes, sir.
Now the question is how to calculate this kind of, when you have this kind of nonlinear equation, okay, how to calculate this value. That means how to find the root of this equation. Okay, now this can be done in 3 ways. Okay, let me go slowly. Maybe I'm going fastly. The first approach is a graphical approach. Graphical approach. The second approach is known as bisection method. Okay. Third method is known as false position method. There are other methods as well. In this experiment, we will only see these 3 approaches. Method. Okay. So let's start with the graphical approach. Okay. Now, graphical approach is not accurate. That means you cannot exactly find the root of a particular equation using the graphical approach, but it can provide you with a good estimate. Okay. Good estimate of where the value may lie. Okay, where the roots may lie. Now, how to apply those things? How to apply this? So, say for example, let's come here. Okay, let's see the equation from 2. Okay, so this is the equation, right? And these are the values. Okay, so I want to change the value of C from 0 to, say for example, 50, and I need to check the value of the function, what the function becomes. Are you getting me?
Yes, sir.
From this, in this equation, I want to check different values of C. Start from 0. If I start from 0 or 1, what is the value of this function of x or function of C, whatever I say. For 2, what is the value of this function? Then using the values of C, is C, and placing the values of function of x here, I want to check how the graphs look like. If the graphs looks like this way, as the C is increases, let's say function of x, the curve looks like this. So this point, this intersection point, this is my root, right? For the value of C, for this value of C, f of x becomes 0. So that is the root of my equation. Are you getting me?
Yes, sir.
Others, only one person is answering. Are you getting me? Or
Yes, sir.
so let's come to MATLAB. Okay. So what do you want to do in MATLAB? I want to create this function and check for different values of C. I want to create this graph first. Okay. Let's come here. So let's write a function. If you remember how to write a function, first we start with the function. Let's create it in a script. Okay. Function, that is the reserve word. Then out, that is the output variable. Then the name of the function, say for example drag. Okay. Then the value of C. Is it clear? First the function, that is the name. This is the output variable. Drag is the name that I'm giving my function name, and C is the input variable. Then let's place everything one by one. So for example, x1 is exp, exponential e to the power minus 0.1468 multiple by that C. Okay, this is one term. This is the x1 term. Then x2 is equals to 1 minus x1. 1 minus x1. You can do these things in a single line. I'm just separating it out for better clarity. So x3 is equals to 667.38 divided by C. Okay, so my out is equals to x3 multiplied by x2, okay, minus 40. Okay, then this is end. Let's save it. Z drag. Is it clear? I have just written this expression. Let's remove all of those things. I named this one as x3. So this was named as x3. This portion e to the power eto was named as x1.
1.
This entire portion was named as x2. Okay. Then output was x3 multiplied by x2 minus 40. Okay. I just did that. I just wrote the equation with respect to c. So c is my input variable and this is my output variable. Is it clear?
Yes, sir.
Okay. You can do it in one line as well. I just, for clarification, I just do it like this. Now, let's drop it here. Now, so what I want to do here is that for different value of c, say for example, for drag 2, what is my value of my function? For 2, I have 44.9. That is too much, right? I need a value of c for which this value becomes 0. Is it clear?
Yes, sir.
So if I write, say for example, drag 8, increase. So it is decreasing. That means if I increase further the value of c, it will slowly go towards 0, right? Let's check drag of 12. It is 6.06. So if I go further, I might get some value that is 0. Is it clear?
Yes, sir.
But there is one thing. Should I try out all the values like this one by one? This is a tedious work, right? I am checking one value after one value and one value. What if I want to check like this, drag of 2 is to 20? I want to check all the values within this range, say 4 is to 20. Okay. If I want to check this, okay, I can check all the values at the same time, right? This is better. Are you with me?
Yes, sir.
Yes, sir.
But will it work? If I write this, it is going to give an error, throwing an error. What is the error? Error using this sign. That means, say for example, when you are performing the factorial operation in MATLAB, if you write factorial of 3, you get 6. If I write factorial of 3 is to 5, that means I'm giving an array. I will get an array. 6, then 4 is 24, then 120. That is what MATLAB provides us, right? You can check here. So for example, factorial of 3 is 6. Again, factorial of 3 is to 6 equals to 6, 24, 120, 24, 720. What does it actually mean? This means that factorial is a function in which you can provide a single value, that means a number. You may also provide an array as an input as well. MATLAB will automatically work. If it is a numerical value, it will perform the operation. If it is an array, it will perform the same operation. It can automatically handle both data types. Are you with me?
Yes, sir.
So this is known as the polymorphism feature. Polymorphism feature of MATLAB. Okay. I talked about these things in last semester as well. So polymorphism feature of MATLAB, that MATLAB can handle, MATLAB functions can handle different types of input. It can be a number. Okay, it can be an array. It can be a cell. Okay, depending on the function. It can be a string. It can handle different types of inputs or a table. All of these things. So that is known as polymorphism. If you try things in Python, you will see most of the times Python functions will fail because Python does not have this feature. Okay. Something that you already saw in the factorial function that we use. If you use the math.factorial, that is another function, math.factorial. Math is the library in Python. Math.factorial of a vector. Say for example 3 is to 5. You will see this is going to throw an error because it does not handle an array. It only takes an integer value. But if you write that scipy that I showed you, scipy.something.something special.factorial, then it can handle that array like this. Okay, so that is the polymorphism feature we're talking about. MATLAB functions automatically have this polymorphism feature. Is it clear?
Yes, sir.
So now our function, the function that I have created here, drag, that function does not support this array. That means my function is not created properly. It only supports C as a integer value. It does not support C as a array. So I have to do something. I have to do something so that my function supports an array as well as an integer. Is it clear?
Yes, sir.
Okay, so how to do it? Very simple. The C can be a vector, right? So the division should be a dot division. Okay, then where do I need more? X2 is 1 minus x1, that's fine. Dot multiplication,
Sir, in the last line, maybe dot
x3,
multiplication. is okay.
x3 into x2. Dot multiplication. Yeah, I cannot hear. Another person is.
Last line. Sir, the last line.
Yes, last line. Yes, this one, right?
Yes.
Yeah, you are breaking up a little bit. Let's try. Let's see whether it is working. As you can see, now my function is working. So that means I have made my function. I have provided my function the polymorphism feature now. Now, as you can see, from 4 to 20, the value is from 4, that is 34, 29, 25. It is gradually decreasing. And here, 1.56 and minus 0.42. Somewhere in the middle, I have the 0 value, right?
Yes, sir.
So what is the value is what is the exact value? How can I find that? I can find it, I can try it using a graph. So it is in answer. So if I click answer, then go to the plots tab and use the plot option. Okay, it is easier. You don't have to write anything. So I have to find the 0 value, but it is not clear from here, right? So I can do something that is known as grid on. If I write grid on, and now if you check your function, now it is much more clear. You know the grid. So this is a 0. The y-axis value is 0. You come here, here, close to this portion, that is close to 12, right? 10 to 12. Within this range, you have the value. Is it clear? So within this range somewhere, I don't know
Yes,
the
sir.
exact value, but within this range, somewhere in the point, I have the exact value, the exact root of that equation. Okay. So we can say from there may be some problem also. Yes, why was that here? So we can assume that from here, we can assume from whatever we created that the root should be within 10 and 12, somewhere within this range. Okay, using the graphical approach, I have estimated the search within this range. Do you have any questions up to now?
So, sir, when we are given such type of problems,
Yeah.
firstly, our approach should be a graphical way.
Yes, graphical way, you can take the limits. You are closing the limit to a certain range, because when you are applying the other methods like the numerical methods, why did I write? Okay, the other methods like this numerical methods, this can be computationally expensive, that we will see later when you are searching for a long range. In the graphical approach, you can simply estimate your search within a small range. Okay, is it clear?
Yes, sir.
Now, so what if I want to find the value directly from this graph? Can I do that? What is the exact point that is actually making this work? And that means the exact point where this line, our graph, has 0, y value is equals to 0. How can I do that? Okay, you can actually do that. What is the intersection point? You can find that. You have to write a function for that. Just come here. So First, I need x value and y value. Okay, the function is poly x poly. One polynomial, another polynomial. As you can see, the function takes x1, y1, x2, y2. x1, y1 means the first graph. So our curve looks like this. So this is my graph, one graph. So this is my first graph. And this line, this is the y is equals to 0 line. This is my second graph. This is the intersection point that I want to find out. Okay, this is the intersection point. So how do I do that? First, I write the equation of this graph. Then I write the equation of this y is equal to 0. Then I'll find the intersection point. So what is the first one? 4 is to 20. 4 is to 20, comma, drag. That is my function. Function taking 4 is to 20. Okay, this is the x value. This is the y value. Okay, that is my first graph. Are you with me?
Sir.
Hello,
Yes, sir.
are you guys with me? Or am I
Yes,
breaking
sir.
up?
No, sir,
Yes, sir.
your voice is all right, sir.
Okay.
Yes, sir.
Acha. So this is my first graph. What is the second graph? The second graph is this line, right? This line. So what is this line? From 0 to 20, that is, say for example 0 to 20, that is my x value. And what is the y value? Y value is always 0, right? So I can write like this way. From 0 is to 20. From 0 is to 20. And what is the y value? That is zeros. Zeros of 1 comma. How many values are there? 20 values. So 21.
Infinite.
Is it clear?
Sir, shouldn't it be infinite, something like that?
No, no, no. At this, I am plotting the graph of this line. So this line has for 0, 1, 2, 3, up to 20. For each of the value is 0, right? Y value is 0. I don't
Yes,
need
sir.
to go to infinity. I can go up to 20 or 25, whatever that is. I don't need to go for all the way. I just need within this range. Okay. If I write like this, as you can see, the x value is 14.7853. So that is the cross section point. That is the point. That is the cross point. 14.78, where we are getting the value, where my root lies. Previously I made a mistake here. Let me check.
Sir, but in the
Yes, wait.
approach, the range was
Wait. Yes, I remember. I made one mistake there. The mistake, can you see what was the mistake? Okay. Here. Acha. As you can see, when I was plotting this graph, when we are plotting this graph, okay, when you are plotting this graph, what does this x-axis represent? This x-axis does not represent the value of 4 to 20. It is actually representing the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Do you understand now the mistake? The x-axis is not representing the value of 4 to 20. It starts from 0, but I don't have anything on 0. Okay, let me clarify a little bit more. If I write plot 4 to 20, comma, that of 4 to 20. Now is it clear? Now it is on the same axis. Now as you can see, within 14 and 16 lies my value. Do you understand now?
Yes, sir.
Previously, when I was plotting from here directly, the x-axis was not the 4 to 20, not that. It was the index. It was using the index by the default value of x-axis. It was not using the value, original value of c that we are placing. If I plot like this way, using x and y, then I can see that within 14 and 16 lies my root of my equation. Is it clear now?
Yes, sir.
Okay, so using this poly x poly function, I already know the exact value 14.78553. But this is not advised normally. You have to use a numerical approach. Use a numerical approach to find this value. Now, how do I do that? How do I use the numerical approach? Do you have any questions up to now? Anyone?
Got disconnected for a bit. So why did we take the value of C 4 to 20 vector? I didn't get that. Why?
I just
did
make an
this
approximation. I just make an estimate. I checked from
4 to 20?
previously I checked. Say for example, drag 2 was 44, drag 8 was 17, drag 12 was 6. So I estimated that within the range of 15 or 16, it will go to 0. So I made that estimate like this way. Okay.
Yes.
Okay. One thing, the plot function works like this. If you only use plot like this, plot of y or plot of x comma y, the first time this y value was using the index as a x operator. It requires y value as well as x value. First time I didn't provide the x value. So normally it was using the index of this y like this. I can also specify the x value as well. So it works both ways. Okay, be careful at these things. Achha, now let's start with how to use the bisection method or the false position method. But before we do that, let me go a little bit further. Achha. The graph can be different types. Okay, let's do some graphs. Okay. Say for example, this is my x, okay, and this is my function of x. Okay, so if this is the scenario, the graph was like this. Okay. So for example, this is the scenario. For our scenario, the graph looked like this, right? Are you viewing this? Can you see this?
Yes, sir.
Yes, sir.
For our scenario, the graph looks like this. So this is the root of our equation, right? Okay.
Yes, sir.
So I can make a estimate of this range and this value. Say for example, this was my 14 and this was 16. Okay. For 14, my value, the value of function of x was something like this. For 16, the number of value was something like this. So I can estimate that within this range, so this line, the root of my equation will be available. Is it clear? So the lower limit is
Yes,
normally
sir.
represented as x suffix l. The upper limit is x suffix u. Okay. The same way here. So if this is the root of the equation 0, so I can assume two value. This is my xl, this is my xu. Okay. Lower limit and upper limit. Using this lower limit and upper limit, okay, I want to find whatever inside. Okay, so xl and xu, this is the limit. Okay, I am saying that my root of my equation will be within this range. Okay, but the problem is, what if the graph does not look like this? What if the graph looks like this? Okay, does this graph have a root?
No, sir.
For value of x, and function of x, this graph does not have any roots. Okay. So if you choose two values of xl and xy, the same range, same value, you will have no value. So this function does not have any root. So for no value,
Sir,
yes,
can we have imaginary root in that case?
in a complicated imaginary root, for this numerical scenario that we are using, imaginary root will not work. For later scenario, it might work. I have to check. Okay,
Okay, sir.
Okay. Now this is one curve. So what if the curve looks like this? Then do we have root?
Yeah, two.
Two
Yes,
roots.
I have two roots. One is here, one is here. Now I have two roots. Okay. So say for example, these are the roots. And this is the range of XL and this is my XU. This is XL and this is my XU. So within this range, I can also have two roots. So what if my graph looks like this? Okay. Okay. Say for example, this is my XL. This is my XU. How many roots do I have?
Three.
I have one root, two root, three root. Okay. So the graph can look like in different shapes. Okay. Now for all kinds of graphs, this one will not work. There is a condition. What is the condition? The condition is it will work if my XL and XU are in the opposite sides of the x-axis. As you can see, in this line, XL and XU were on the opposite side of x-axis. Okay, for this one, XL and XU was on the opposite side of x-axis. If this satisfies that XL and XU are on the opposite side of x-axis, then I will definitely have a root. I can have one root, I can have three root, I can have five root, but I will have a root. Is it clear?
Yes,
But
sir.
if XL and XU like this way, this scenario and this scenario, if XL and XU are on the same side, then this scenario can happen. I might have no root, or I may have even number of roots. Okay, even like this. Okay, if XL and XU are on the same side on the x-axis, then my equation might not have any root, or they may have even roots. And there can be some more complicated curves when now for none of this approach will not work as well. For example, for multiple roots, we will see those things in later chapters. For now, for our this method to work, our numerical methods to work, okay, I need this condition that XL and XU should be on either side of the x-axis. Is it clear? Yeah.
Yes.
So that is my first condition. From here, the condition. What is the condition? XL and XU should be on different sides. X-axis. Not actually XL, that is the function of XL, the value of at this point, the value of the function at this point. I'm going there. So any questions up to now?
No, sir.
Okay, so now we'll go into the numerical method that is known as the bisection method. Okay, that is known as the bisection method. Okay, so the bisection method is valid. It will work only when it is not actually XL and XU, as you see here in the curve. When I'm saying XL and XU, I'm actually meaning XL and XU values 14 and 16. I'm actually meaning the function of XL. Okay, the value of the function should be in opposite side. Okay, is it clear? The value of the function, not the value of XL and XU, the value of the function at this point, that should be in opposite side. Are you guys there?
Yes, sir.
Okay, my electricity is gone, so I am in data mode. Okay, so the bisection method says the condition is actually function of XL. Okay, the value of f at this point and function of xu, they should be on the opposite side of the x-axis. Okay, only then this method will work. So this is why, okay, so the condition can be written as like this: f of xl, if I multiply these two values, multiple by f of xu, this should be less than 0, right? One is positive, one is negative, so multiplication should be a negative. Is it clear?
Yes, sir.
Achha. So what we do here, what we do in bisection method is, I have this graph. So I have this graph like this. I take this value and say, for example, this value. This was my XL and this was my XU. I want to find the value of this one. So what we do is chopping. Okay, I chop it. I gradually reduce the range, okay, and check whether my estimate is correct or not. Okay, whether, okay, we'll discuss it later. We gradually decrease the range to this one, this range, then more iteration, then closer range. The higher the iteration, okay, the closer we get to our desired point. Is it clear?
Yes,
The
sir.
more iteration, we'll just close into our desired point like this. So this is known as a binary chopping. This is called binary chopping. Or if you are familiar with algorithms, it is similar to divide and conquer algorithm. Divide and conquer. Similar to like this, similar approach. Achha. So let's see how to do that. How to do that. How to use that. So first, number one, what we'll do is that I'll choose XL and XU such that f of XL, okay, f of XL multiplied by f of XU is less than 0. So this is my first condition. This has to be met. If this condition is satisfied, the second approach is I have to calculate XR. XR is equals to XL plus XU divided by 2. Okay. After this, I will calculate XR. Then third approach, and the third process is, we'll see an example later on. Okay. If this one is less than 0, sorry, not this one actually, function of XL multiplied by function of XR. This was XU. After I calculate the XR from this XL and XU, the lower limit and the upper limit, I calculate the XR. Then I multiply it using function of XL and function of XR. I calculate this point. If this value is less than 0, what I do? I'll make the XU value equals to my XR. If this value is greater than 0, then what I do? I'll make the XL value equals to XR. Okay. And if this is equals to 0, that means terminate. That means I have reached my destination. Okay. So understand, whatever what I'm doing here is that first, this is my XL, this is my XU. Okay. I'm taking the average of it. XR into XL plus XU divided by 2. So I'm choosing one point like this, arbitrary point. Then I'm performing the operation, seeing whether the multiplication of these two is less than 0, is greater than 0, or equals to 0. If it is equals to 0, then this XR is my desired root. Okay. If it is less than 0, I am reducing the value of XU. If it is greater than 0, I am increasing the value of lower limit. Okay. Let's see an example, mathematical example. It will be much more clear. Okay. Are you with me? Is it?
Yes, sir.
Is it clear? Or let's see. 12 and XU is equals to 16. Okay. let's first check. Okay, so Excel and X16. I have the values here. If you have a calculator, use the calculator. Create a outline. Okay. So as you can see, now we have the value. So I am assuming Excel equals to 12 and Excel equals to 16. So Excel equals to 12, I have 6.06 and 16 is minus 2 point something. So if I multiply these two, what do we have? Minus 13.75. Okay. So f of Excel, that is the first step. F of Excel multiplied by f of XU, that is equals to minus 13.5. Is it 13.7? 13.7. This condition is satisfied, right? This should be less than 0. This is less than 0. Is
Yes,
it clear?
sir.
Okay. So let's go to the next step. I have to calculate XR. How do you calculate XR? XR is equals to 12 plus 16 divided by 2.
14.
That's equals to 14. Second step is done. In the third step, what is the third step? Function of Excel, that is the lower limit, and this XR, f of XR. Okay. So what is the value? 12 and 14. 12 term is 6.06. What is the 14th term? It's 1.56. 1.56. The value is
Will not be
9.45.
valid.
That is equals to, no, there does not come the validation right now. 9.45. This is the value f of Excel. I have to check which condition is met, right? What is
Oh,
the
okay, sir.
condition
Got
now?
it, sir.
It is greater than 0, right?
Yes, sir.
If it is greater than 0, I will, which is greater than 0. That means I'll change my Excel to XR. XR is 14. So Excel becomes 14 now. Is it clear?
Yes, sir.
Now I repeat the operation. I go in the home side again. How do I do this? Now my new Excel is 14. XU is same. XU is 16. Now I calculate the first section. F of 14 into f of 16. If I calculate these two, 14 and 16, that is 1.56. That is 1.56. 14 is 1.56 minus 3.54. That is equals to minus 3.54. Okay. This condition is satisfied, right?
Yes,
Yes,
sir.
sir.
Yes. Now you check this condition, not here. Here you change the value, you update the value. Now this is minus 3.54. Now what you do is the second step. Again calculate XR. What is XR? 14 plus 16 divided by 2. 14 plus 16 divided by 2. That is 15, right? Okay. What is the third step? I have to calculate f of Excel into f of XR. Okay. Excel and XR. Excel is 14, XR is 15. Let's come here. My 14 is 1.56 and my 15 is minus 0.428.
4280.
428. It is minus 0.667. Question. That is equals to minus 0.67. Now check which condition? The first condition, right?
Yes, sir.
The first condition is met. So since it is less than 0, I will make xu, the upper limit, is equals to xr, that is 15. Xu equals to now 15. Are you with me so far?
Yes, sir.
Yes, sir.
Now I will go again. I will go to the front side again. In the third iteration, I have xl equals to 14 and xu is now 15. I'll perform this operation again. Okay, as you can see, I started with 12 and 16. In the second iteration, it became 14 and 16. Now it become 14 and 15. If you keep doing it for in some iteration, say for example 10 iteration, n is equals to 10, within this range, you will see, you'll find the value xr very close to our original result. Our original result that we found. What was the value we found? Yeah,
14.6.
14.78. That is the value. If we keep iterating, we'll get very close to 14.7853. Are you with me?
Yes, sir.
Yes,
The
sir.
question is that how long do we iterate? How long do we iterate? Now, to keep a condition, I will use a condition that when should I actually let myself out from the iteration process. I should not keep iterating again and again and again. Okay. So we'll do that using something that is known as the approximation error that was covered in the last class. Approximation error. So what is the approximation error? At each iteration, I will calculate the approximation error. The approximation error was epsilon of a, that is equals to xr new, the new value that I just calculated, minus xr of old, the old value that was, okay, divided by the relative one, the relative approximation error, xr new. Okay, I'll take the modulus. I will take absolute relative approximation error, okay, as a percentage. Okay, is it clear? Let's come here. Let's calculate here. Let's see. So here, let's say in the second iteration. In the second iteration, xr was 15, right? In this iteration, xr was 15. The
Yes,
previous
sir.
xr was 14. Yes.
Yes, sir.
Yes. So in the present iteration, say for example, the second iteration, xr was 15. The previous iteration, xr was 14. So I have to minus this 2, that is 1, divided by this value, the current approximation. If I do that and multiply it with 100, I will see that in this scenario, the epsilon a is equals to 6.67%. Is it clear how I calculated this?
Yes, sir.
The current value is 15, previous value is 15 minus 14
by 50
divided by 15
into 100%.
multiplied by action, multiplied by 100. So that is my epsilon a that I just calculated. Now, this is the second iteration. In the next iteration, I will again calculate epsilon a, and you will see this epsilon a will decrease because I am reducing the range. The lower the range, the epsilon value will keep decreasing. Okay.
Yes, sir.
So I will use that as my tolerance level. Okay, sir. A tolerance. Tolerance means at each iteration, I will calculate this epsilon a. Say the tolerance level is, say, for example, 1%. That means whenever my epsilon a becomes less than 1%, I will assume that my iteration is done. The value that I get, the xr value that I get is my root. It is the approximated root. Is it clear?
Yes, sir.
So the lower the tolerance, if I make it 0.01%, that means I have to iterate further. The value will be very close to xr, this value, the true value. Okay. The more I iterate, the more closer I will get. Okay, but again, the more I iterate, the complexity, the time complexity increases. Program's time complexity. So any questions up to now? Any questions about this bisection method?
স্যার তার মানে কি স্যার ফার্স্ট যে মেথড ইউজ করছে গ্রাফিক্যাল এস্টিমেশন ওটা হচ্ছে একদম এক্সাক্ট ট্রু ভ্যালুটা দিয়ে দিচ্ছে আমাদের
True value actually আমি দেখাই দিছি just after group I just showed you how to use the graphical method to get the true value. Okay, but if you check your PDF, that is the experiment, you will not find it here. Okay, so using the graphical approach, normally it is not done this way, but MATLAB actually provides the function to estimate the intersection. So I use that to show you, but normally you have to assume that using the graph that you get, using the graph that you got, I got a range. I got a range from 14 to 16.
এক্সেল আর
I was not,
এক্সইউর ভ্যালুটা আমরা নিব
yes,
ওকে
I didn't know the exact value. So you just think of it like this way, that I don't know how to calculate the exact value. From the graph, I'll just assume this range, and within this range, I'll apply the numerical method to extract my root, exact root.
স্যার মানে গ্রাফিক্যাল মেথডটা তো স্যার আমি মানে ট্রু ভ্যালুটা পাচ্ছি না স্যার, এখানে বেস্ট অ্যাপ্রক্সিমেশন পাচ্ছি, ঠিক না
Yes,
স্যার?
yes, of course. True value আমরা কখনোই পাবো না। Okay, and that is the best approximation that will consider as my true value. Okay, and as you increase the iteration here using the numerical approach, you will see it will get closer to closer this range. Okay.
Yes, sir.
Also. So any other questions up to now?
No, sir.
Okay. Now the thing is how to do it in MATLAB. It is actually very simple. You can do it very simply. I'll just show you in a minute. Others one was, let's finish it this one first, the bisection method first. Okay. One now. So let's start with my XL is equals to 12, my XU is equals to 16. Okay, let's run it. We are here now. What is the first approach? What is the first approach?
The স্যার যে ফাংশন দুইটার গুণফল স্যার 0 চলে আসে হবে।
Yes, as you can see, I have previously I just this one. You have to create something like this. That will be easier, or you can do something like this. You have the function already created, drag, right?
Yes, sir.
So the f value is equals to drag of 12 multiple by drag of 16. Okay. So this is the value minus 13.7698. That is negative. So the first condition. Now let's go to the XR. How do you calculate the XR? Is equals to XL plus XU divided by 2, right? Let's run this. That becomes 14. Now what will I do? I will calculate, let's say, y is equals to drag of XL multiple by drag of XR. Drag of XL multiple by drag of XR. Okay, so what is my value? 9.48. Then I'll use the condition. if y is less than 0, y is less than 0, what is the condition? Make XU is equals to XR. Else if y is greater than 0, then make XL equals to XR. Okay.
Yes, sir.
Remove this one first. And the last thing is else. That means if they are 0, then what do I want to do?
Return.
I want to break from the loop. I have not given a loop here, but I'll put it later. So break. Okay, let's keep it here right now. I want to exit from this iteration. Okay. Now understand. So this is the first step. So for now, I don't need the else. Let's put it here. If I run this one, if I run this one, as you can see, Excel is becoming 14. So Excel is becoming 14. Are you with me?
Yes, sir.
Okay, so now I have to repeat this operation. I have to go where? I have to go here again. XR. Using this 14 value, I have to perform the calculate the XR, then calculate the Y, then perform this operation again. So instead of doing it, writing it again and again, I can put everything inside a for loop, right? Or a
Yes.
while loop. But one thing is remaining, that is my EA, the approximation error that I will use as a tolerance. Okay. What is the EA? That is my XR that I just calculated minus the previous XR. The previous XR. Previous XR. XR minus previous XR. I have to take the absolute value. Absolute value divided by the XR value. Okay. Then multiply it with 100 as a percentage. Is it clear?
স্যার তাহলে কি
Yeah, but-
এক্সেল এর ভ্যালুটা একটা ভেক্টরে স্টোর করব?
You don't have to store it. Let me finish it now. We'll see later. So previous XR I have not calculated here. So let's make it fast. At the first iteration, let's define it here. At the first iteration, let's make it previous XR as 0 because I have not calculated. Okay. So if I use it like this way, as you can see, at the first iteration that is 100% because it was considered as 0. In the next iteration, now the Excel has become 14. Okay. If I calculate it again from this one, from this approach, XR is now become 15. Then Y, the Y is now minus 0.67. If I use this right now, XU becomes 15. And what is the EA? Oh, sorry, I have to add another line. After this, I have to update the previous XR. Previous XR will become the current XR. Okay. Now if I calculate this one, no. Okay, so I have to do it again. Achha. Any questions up to now? Let's put it inside a for loop. It will be clear then. While, same as for, you can use a while. While EA is greater than 1. So I'm using the tolerance as 1. While EA is greater than 1, first calculate XR. Then calculate Y. Then calculate if. Then the if is condition. Okay. Then let's remove this one. So that means when if my Y is 0, I will just break from the while loop. Okay, I
তো
will
while-এর নিচে একটা এন্ড চলে আসছে।
yes, আরেকটা end আসবে। তার আগে আমাকে ইয়েটা ক্যালকুলেট করতে হবে। So let's give this EA now. So the EA is calculated from the previous XR. Okay. This one, right? This one. Okay, is it clear now? Anything else? I have to have a break. Then this end. Okay. So my loop is created. Whatever is remaining, XR calculate no, Y calculate no, XU value, XR value, break up.
স্যার হচ্ছে প্রিভিয়াস এক্সেলটা সেট করতে হবে।
Seeing it.
স্যার ই এর ভ্যালু স্যার সেট করা লাগবে ইনিশিয়ালি ই এর ভ্যালু
Equals to 100. This is a higher value. Okay, I have to use it here. It should be okay now, right? Okay, let's initialize again from 12 and 16. Okay, let's run this one. Let's see if it's okay now. Okay, so yeah, it is closely okay. So as you can see, first Excel was 12, Excel was 16. Can you see?
Yes, sir.
Okay, first XR was 0. I assume that the initial XR was 0. That is what the previous XR value. At the first step, it is 0. Then I calculate the XR value, that is 14. Using 12 and 16, I got 14. Then I calculate the Y value, that is 9.48. From that, I found that XL should be 14, and the error was 100, right? Yeah, approximation was 100%.
Yes, sir.
Then loop back, because this condition is satisfied. Then come here. The previous XR becomes the current XR, that was 14. Okay, and the new XR
Yeah.
becomes 15. Are you clear? Is it clear?
Yes, sir.
Everyone clear?
Yes, sir.
Other. Okay. Then you calculate the Y again, that is this value. Then this condition is checking that XU becomes 15. Then the EA you get is from this state is 6.67. It is still greater than 1. So you repeat this portion again. The next step you find EA is equals to 3.45. Okay. Go further, EA is equals to 1.69. Okay. At the last step, you find that EA is 0.84. When you find that EA is 0.84, this condition is no longer satisfied. You get out from the loop. Is it clear? And
Yes,
the
sir.
final XR that you get is 14.8750. Our original was 14.7853. So if we reduce this one a little bit, 0.5, okay, run this again, as you can see, the final XR becomes 14.8125. It is much closer, right?
Yes, sir.
It is much closer. So first 14.81. What was the previous one we got? 14.84 na 5.
4 maybe.
84. Now we got 81. If you reduce the tolerance value to say for example 0.1, you will see it will be much more closer. It is now 14.7734. It is now becoming 14.7734. Okay, 7734. It is very close to this one. It will keep shifting. It will at the top range when you're calculating, it will keep varying gradually. Okay, so one thing you can do here is that you can store these things in a value. Let's run this one. Hold on. সমস্যা কি হচ্ছে কাশ ফেলে নাকি ওকে oh. Achha, that's why the reason. Achha. Now it is clear. Now it is going to work. So do you understand what was the problem previously? Yeah. Are you guys there?
Yes, sir.
Yes, sir.
What was the problem? Why it was not working? It was not working because after I run this one, EA already has become 0.08, okay, which is lower than this. I have not run this cell again. Okay, you have to be careful. I did not run this cell again, so it was not calculating any value for that. Okay, so this kind of error will occur. That's completely fine. So
Sir, is it
And-
because of the previous from the previous result?
yes, for the previous result, it was saved as EA was already calculated as 0.0 something. Then when I was trying to run this one again, my EA has to be initialized again with 100. I didn't initialize it. That was the problem.
Sir, cannot we use that clear and CLC command?
Yes, you can use. Of course you can use. I don't normally use that. This was the first time I faced this kind of thing. Okay, let's come the matrix. Okay, if I visualize the mat now, the last mat. Okay. As you can see, how the value is changing from 14, it become 15. Again, it become 14.5, 14.75, 87. It will keep changing. Okay, it will not be always decreasing or monotonic, not monotonic. It will decrease, sometime increase and decrease. It will fluctuate, and gradually it is fluctuating, right? And gradually it come to a shift value. Okay. Gradually, if you go further, this line will be a straight line like this. Okay. Are you getting me?
Yes, sir.
This is the final value, the extra that you are getting. It is shifting like this way. It is shifting like this way, and gradually it will take a straight line. That means when it is going to a straight line, that means I have reached the convergence point. Okay, converge. That means my function has converged. Is it clear?
Yes, sir.
Any questions up to now? Anyone?
স্যার একটা কোশ্চেন ছিল যে
Yes,
আমি
of course.
লুপ দিয়ে না করে যে ভেক্টরাইজেশন দিয়ে করার ট্রাই করি, while লুপে কি করা পসিবল এটা?
In this scenario, the problem is the output from each iteration. If, as you see the if condition, from the output from each iteration, I am updating the value. So when there is this scenario like this, I am updating the value at each iteration. You cannot use vectorization like that way.
Okay.
Are you getting me? If
Yes,
it was something that a function you want to apply a function to all the values in a matrix on an array, then you can use vectorization. But in this scenario, based on this condition, I'm updating the value of XU or XL. Since I am updating the value XL and XU at each iteration, I cannot vectorize it that way.
স্যার তাহলে স্যার ফর এক্সাম্পল ল্যাব 1 এর যে সেকেন্ড এইচডব্লিউটা ছিল,
Yes.
ওইখানে কি আমরা স্যার ভেক্টরাইজেশন করতে পারতাম?
Yes, কোন এক্সাম্পল ছিল বলেন? আমি এখন দেখিনি।
আমাদেরকে বের করতে বলেছে যে ই এর ভ্যালু 10 টু দি পাওয়ার -20 চেয়ে ছোট হতে হবে, এমন
আচ্ছা।
ভ্যালু বের করতে।
আচ্ছা, so for that scenario, is it clear now, everyone?
Yes, sir.
Okay.
Yes,
So
sir.
the question that he asked in your lab assignment, that it was something that EA has to be less than something like that, right?
Yes.
So the normal way, if you use vectorization, what we did in case, we start with 0 to 10, something like that. We created a vector and performed the operation, right?
Yes, sir.
Okay. Now, if you use for loop instead of vectorization, it will be slower. So how do we make this condition like this? Then the question is how do I make this condition satisfied? So what you can do, you can use the preemptive case that I will calculate the vectorization for 0 to 30. Okay. For 0 to 30, you will get a whole vector, something like this. Then say for example, this is your x. So you will extract the value x where value of x is less than this value. Say for example, this is 0, 1, 1. You are Boolean masking it. You are using Boolean masking. So when x is less than 0, 1, 1, so the portion that satisfies this range will be extracted out. That means you did not need to calculate this range. This is enough. Do you understand my point?
মানে স্যার
Yes, sir.
ইনিশিয়ালি আমরা স্যার এক্সট্রা স্পেস নিয়ে ভেক্টর
Yes.
অ্যাসাইন করে দিই।
ইনিশিয়ালি আমি এক্সট্রা এক্সপ্রেস নিচ্ছি, আমি ইনিশিয়ালি একটা গেস করতেছি যে আমার কত হাউ ফার ডু হ্যাভ টু গো টু রিচ দিস লিমিট, আই এম মেকিং এ গেস। ওকে, দেন আই এম এক্সট্রাক্টিং দ্য পোর্শন দ্যাট স্যাটিসফাই দিস কন্ডিশন, দ্যাট ইজ মাই আউটপুট ভেক্টর।
ওকে
আর উইথ মি?
জি স্যার, তাহলে কি
Now-
এটা স্যার লুপের চাইতে বেশি এফিশিয়েন্ট?
Yes, of course. Again, if you are using loop, it will still outperform the loop. Okay, if you use the vectorization approach, that is the basic way. But when you have much more complicated scenario, when the calculation is much more costly, then what you will do? What you can do is one approach is called discretize. Discretize the value of n. Discretize n. That means that first you perform the vectorization operation from 0 to 10 and check whether this is satisfied or not. Okay, if it is not satisfied, then perform the operation from n equals to 10 to 50, say for example, or 40. Okay. Again check whether this is satisfied or not. You perform this operation within this range in a vectorized manner. Then again start from n is equals to 14 to 80, 40 to 80, like this. Okay, you discretize the n into certain range, then you perform the vectorized operation. So instead of writing 80 for loops, you are writing 3 for loops, right?
জি স্যার, বুঝতে পেরেছি।
Yes, sir.
For first iteration, you are performing vectorized operation for n is equals to 10. If not, then perform for this range. Okay, using the value from 10, you need only the last value. Using the last value, you can start from 10 to 40. Okay, you don't need the other values. So like this way, you can do it the same way in this scenario as well. But as you can see, using the graphical approach, we have already performed the limit into 14 is to 16. That is already very close. So you don't need to do it. You don't need to do this kind of complication. This kind of complication you will need when you have much more complex scenario. Okay, complex boundary, especially in electromagnetism. Okay, you'll see it later. Any questions up to now?
No, sir.
So this was the bisection method. There is another method that is known as fixed position. Okay, what is the formula? False position. Okay, as you can see, everything is same. Everything is similar to this false position algorithm. This is another algorithm similar to this one. Only difference is how I calculate the XR value. As you can see, previously I was taking the average, but now it is taking XU multiplied by function of XL minus XL multiplied by function of XU divided by this one. Every other things are same, only this portion is different. Are you with me?
Yes, sir.
Only this thing you can do it by yourself, I believe. Any problem?
No problem, sir. We will try.
Okay, you can do it by yourself. So I wanted to give it as a lab task, but I don't want to. This should be given as a lab task. Then I could see which one of you are actually concentrating in the class or which one of you are sleeping. But it's okay. Okay. Yeah, there is an experiment. There is an assignment like this. Similarly, you will submit it in the next week. Okay. Do you have any questions? If not, we can finish.